All right, guys, welcome to this page of the notes, and what we're going to do is we're going to continue with this idea of solving rational equations. But I told you what will happen sometimes is you might wind up getting an answer that is an extraneous solution, simply meaning when you plug it back into the original problem, it doesn't actually work. So I've got 3 example problems here, 2 on this page and 1 on the next page, where we're going to see, we're going to get solutions, but when we go ahead and check those solutions, some interesting things happen. I want to take a look at them. And I know I got this problem slid way over there for the moment. This one's going to be a little bit longer, and so I just want to give myself some extra space to find my LCM so that I can then slide it back over and leave myself space so that you can see my work. I hate it when I have to squeeze everything in over there on that side. It's frustrating for me. So I'll just give myself some extra space. Here's what I'm going to do. I need to find the LCM for this guy. Well, this one's actually interesting. This is the first time we've seen one where I don't have any constants in the denominator, right? Think about it. In all the previous problems, like I had a 28 down here, or a 12, or a 4, or something like that. But please notice in this one, every single denominator has factors in it, right? Actually, this one's quadratic, which means we'll have to factor it, but it will factor into factors. And so let's start there. I'm going to take this x squared plus 8x plus 15. Let's factor it. You'll find it very interesting what you wind up getting. So here we go. I wind up with x squared plus 8x plus 15. All right, the leading coefficient here is a 1, so hopefully it very easily just factors into 2 binomials. I don't know, let's find out. The easy bit, I need 2 numbers, 2 things that multiply to give me an x squared, which of course is x and x. Maybe slightly trickier, I don't know, let's find out. I need 2 numbers that multiply to a positive 15, sum to a positive 8. And actually, that's not that tricky. I believe a plus 5 and a plus 3 will get me there. Now, why is that interesting? Well, here's why that's interesting. This guy right here, right down here, factors into an x plus 5 and an x plus 3. But please notice what my other denominators are. This denominator is an x plus 5, same as what I got here. And this denominator is an x plus 3, same as what I got here. So it turns out my LCM is actually just going to be a combination of those factors. This x plus 5 factored is x plus 5. X plus 3 factored is x plus 3. X plus 5 times x plus 3 factored is x plus 5 and x plus 3. But you keep each factor the greatest number of times it appears. You only have to keep each factor once, and it's the greatest number of times it appears. So my LCM is x plus 5 times the quantity x plus 3. X plus 5 and x plus 3. So what I'm going to do is multiply each of these guys by this LCM, and go ahead, leave that in factored form, right? Because then you'll see when I multiply, everything drops out. It's beautiful, beautiful the way this works. So let me slide this back over. Now that I know what my LCM is, give myself some space. Hopefully you can still see that. Here we go. All right, so my LCM was x plus, the quantity x plus 5 times the quantity x plus 3. So here we go. I have x plus 5 times x plus 3. That's multiplied by 2x over x plus 5. I'll just do it right now. Those x plus 5s cancel each other out. Then I have minus, it's going to be x plus 5 times x plus 3. That's all multiplied by x squared minus x minus 10 all over x plus 5 times x plus 3. I told you I hated squeezing, and I'm going to wind up having to do it anyway. It drives me nuts. I hate it when this happens. 3 over x plus 3 multiplied by x plus 5 times x plus 3. I am so sorry about that. They just get long, I know. Anyway, the x plus 3 cancels with the x plus 3. Oh, okay. Whew. Here's what's left. Beautiful problem. I love this thing. The x plus 5s are gone, so I'm left with the quantity x plus 3 times 2x. So I'll have 2x times x plus 3. Everything dropped out. X plus 5, gone. X plus 3, cancels each other out. So I have a minus and then just that numerator. So negative x squared minus x minus 10. On the other side, the x plus 3's dropped out, so all that's left is the 3 times the quantity x plus 5. So 3 times the quantity x plus 5. We've got some distributing to do. Distribute the 2x through the parentheses. Distribute the minus sign through the parentheses. And distribute the 3 through the parentheses. It's a distribute palooza around here. Anyway, that gives me 2x squared. And 2x times 3 would be plus 6x. Distribute the minus sign, so a minus x squared plus x plus 10 is equal to 3x plus 15. Awesome, here we go, combine like terms. 2x squared minus x squared leaves me with x squared. Okay, I have a 6x plus x should be plus 7x. I got the plus 10. That's all equal to 3x plus 15. Okay, awesome. Subtract the 3x, subtract the 15, set it equal to 0. It's going to be quadratic. Here we go. I wind up with x squared. Now, 7x minus 3x leaves me with, 4x. And a plus 10 minus 15 leaves me with a minus 5. And it's all equal to 0. So here we go. I've got a quadratic. X squared plus 4x minus 5 equal to 0. We're going to need to factor this guy. Let me slide this on over here a little bit. Oh, I still want to be able to, here. I want to be able to see it. I'll just slide up, go to right there. So there's where we're at. Let me come up over to here. X squared plus 4x minus 5 is equal to 0. We hope and pray, it factors easily. If it doesn't factor easily, then you might have to use the quadratic formula or completing the squares or one of those, sort of a little bit more challenging factoring methods we learned back in chapter 4 for quadratic functions. But let's see how this goes. Two things that multiply to an x squared, well, that's the easy bit. That would be an x and an x. I need two things that multiply to a negative 5, some to a positive 4. Whew. It looks like a plus 5 and a negative 1 will work. Now, they're equal to 0, so the 0 product property will split them up. So x plus 5 equals 0, which means x is equal to a minus 5. And x minus 1 equals 0, which means x is equal to 1. There we go. I've got two answers. X equals negative 5 and x equals a positive 1. I've got to check them both. It's possible that both of them work. It's possible that only one of them works. It's possible that neither of them works, right? You got to check your solutions. So here we go. We go back to my original problem, which is right here. It's fine that it's in factored form. Please, if you FOILed this out, you get right back to what we started with. So leave it in factored form, and actually right away, I kind of recognize which one is the one that's no bueno. Remember, I got a positive 1. Sorry, it's kind of off the screen here. I got a positive 1 there and a negative 5 here, but I look at it and immediately I see, if I plug in a negative 5 here, negative 5 plus 5 is 0. That gives me 0 in the denominator, and division by 0 is undefined. You can't do that. It's not allowed. So I come back down here to my answers, and right away, x minus 5 is extraneous. It's the x equals 1 that works. Again, you can plug that 1 in there, and you'll see that it does. All right? Awesome. So we've seen one now where you get an extraneous solution. Let's keep going and see what happens here. I got another one for you. All right, now this one is almost factored, right? Hopefully you recognize right here z squared minus 1. And we've seen this a few times now here in chapter 8. You hopefully quickly recognize that is a difference of squares. So I'm going to go ahead and just cross that guy out, because I know that actually I could write that difference of squares means it's a z plus 1 and a z minus 1, which is incredibly convenient because this denominator is a z plus 1 and this denominator is a z minus 1. So guess what your LCM is? Yeah. Z plus 1, z minus 1. So what we're going to do is just multiply everybody by the z plus 1, the z minus 1. Those will all go away. So anyway, here we go. Let's see. Actually, should we do it? Yeah, I'm going to write it out. I apologize. I may wind up needing to squeeze. I'm going to try really hard not to. Okay, the z plus 1's cancel, minus the z minus 1's cancel. Everybody still had to wind up squeezing over there. I'm sorry about that. Everybody drops out on that side. I love it. Okay, so here's what I'm left with. 2 times z minus 1. 2 times z minus 1. And then I'm left here with a 1. So it would be, right, because it's a minus sign, so it would be a negative 1 times z plus 1. So I'm left with a minus z plus 1. And then over here on this other side, I just have a negative 2. All right, distribute the minus sign as well, and I wind up with 2z minus 2 minus z minus 1 is equal to a negative 2. Okay, let's see here. 2z, so that leaves me with a z. Minus 2 minus 1 leaves me with a minus 3 is equal to negative 2. Add the 3 to the other side. Z is equal to a minus 2 plus, so I get z is equal to 1. All right, so there we go. There's my solution. That one was a little bit easier to do than the last one. But interesting thing happens here. I got to check my solution. So I have a positive 1. And take a look at this, and actually, pretty quickly, hopefully you recognize, if you plug a positive 1 into this denominator, plus 1 minus 1 gives you 0. You would wind up with division by 0 here and division by 0 here. Division by 0 is not allowed, which means this can't be a solution. But since it was the only answer I got, it does not check out. This one has no solution. I only got one answer and it turned out to be extraneous. It doesn't work, and this rational equation doesn't have any solutions. There are no values of x that would allow this side to be equal to that side. All right, guys, hopefully these are starting to make sense. I hope actually even maybe what you're doing is working ahead and coming back and checking your answers, and if that's the case, I hope those went really well for you. I have one more problem I want to take a look at with you. We're solving rational equations on the next page, so head on over there. I'll meet you guys there.